3.5 Graphical analysis of one-dimensional motion. Graphical method. Motion of object can be explained better by using graphs. There are two common graphs usually used in this chapter. First, displacement versus time graph, which is velocity were found by calculate the gradient. Second is velocity versus time graph, which is acceleration were found by calculate the gradient, and displacement were found from area under the graph. This is the displacement versus time graph. Gradient of the graph is equal to velocity. Next is the velocity versus time graph. The gradient is equal to acceleration. Always remember for this graph, displacement were found from area under the graph. Next, we will continue to patterns of graph and the explanation. Let's look at graph 1. This is graph velocity versus time. If you can see, velocity increase uniformly as time increases. From the gradient of the graph, we can get the positive acceleration. Because of it is increasing uniformly means to the constant acceleration. Graph 2, it still show the positive slope increasing, and from this curve pattern of graph, it's show that velocity is increasing but not uniformly as time increase, and acceleration from this graph is still positive. Graph 3, show the negative slope means that velocity decrease uniformly as time increases. So we will get the negative and constant acceleration. Next, in graph 4 it's show the zero slope. It means the velocity does not change as time increases. In other words, the velocity is constant. If the velocity is constant, we will get zero acceleration. Last one, in graph 5, we can see velocity increase uniformly from A to B, and then remains constant from B to C. It means the acceleration is constant from A to B, and then zero acceleration from B to C. Remember, you can calculate the displacement from the area under graph. So, that's all for subtopic 3.5. I hope all of you can try to do some exercise after this. Thank you for watching and happy learning.